So as you're filing in, there's practice exercises that you can try out, just so you don't sit there idly while we're getting loaded up. So just go down to that exercises section and try out a few of these, see if anything weird happens and you have questions. We're going to rearrange parts of the curriculum because of some quirks on people's setups, but I'll tell you about that in a sec. We have another minute. I'm just saying get started with exercises and try them out. Question? And ask me questions if you have. Yeah, question. What's up?
So back to the function of print.
Function of print, yes.
Is this needed for the \n to work?
Yes. Yes. For it to be evaluated to a new line. Yes. So there's two ways that things are going to get returned, that are going to get shown here when we're looking at them. The first is they're going to get returned to the interpreter, and returning is different from them getting printed. So if I have something, let's say 10 is, when I'm typing in 10 and hitting enter, it's getting returned. When I do print 10, this actually isn't going to work, but print, actually this does work because it then assumes it's a string. But this is technically doing something else. It looks identical, but technically this is returning and this is printing it out. And the reason that this becomes important as a distinction is when we're doing something like that \n. If we did this would actually, actually no, let me put something else. Hello. What am I breaking now? That's a /, that's why. There we go. So ignore that, that's a /, I messed up. So the reason this is important, because when we're doing this versus this is showing you the difference between being returned and being printed. When it's being printed with the print function, it's saying, okay, let's evaluate this, show it to them how they want to see it. When you're printing something out, it should be printed so that you can read it. When you're returning it, it's going to be returned as Python is kind of keeping it around. So it's a little bit, it gets a little confusing, but that's the basics. Yeah, question.
What's the difference between
Print and type as functions. So if I did, so print is just showing us what's back. So if we did type of this, it's going to give us the type of that. So it's going to tell us what it is. In this case, it's telling us again that it's a string. Yeah, sorry, question 2. What's the type of print? Great question. So let's look at the type of print. Let's do this first, but then this probably won't work. So that's none type. Let's try this. So there's the difference here is because of the way parentheses evaluate things. We're trying to find types of a function, but the first thing we actually did up here with type of print, we actually said, okay, print nothing, right? So really what we did up here is we first did print this, which didn't give us none, nothing. So what we ended up doing is we returned this none to type, and basically it's the equivalent of this, I think. Oh no, sorry, not print none. I meant to do type none. Type none. Oops, keep making mistakes. There we go. So let's clear the screen and do that one more time. So type none versus print there. So what was happening here is we were kind of evaluating the print function, and we weren't really giving it anything to print, so it just printed this kind of blank line here, and then it evaluated nothing. So it kind of like, what happened there is print kind of just poofed. It did its thing, and then it disappeared, and then we tried to do type of this. Oops, no, not that. No, we really just did this. Yeah, it's kind of weird because technically print evaluated, it created a little new line there that had nothing on it, and then it ran type of none, which was there. Yeah, sorry. Sorry, it's just making me do weird things now while people file back in. Type, class type. There you go. Are you happy? Are you happy, sorry? So this is you can look into more in the internals of how these things work, but I won't go into too many of those details. Question?
Could you force or tell a function to do something else?
So when functions get defined, you're creating a function, and it's, so I briefly did that, we'll talk about it towards the end, but you're defining a function to do something. I can define a function to do multiple things depending on what you give it. I could define different functions to do different things, but when I pass something to a function, the function's just going to try and do exactly what you told it to do with whatever I give it.
So for example, like print is already
print is defined. Yeah, so print, Python gives us print for free. It gives us len for free, it gives us the string, the str, it gives us int parentheses for free, it gives us print for free. All those are free. It builds those in for us so that we don't have to do anything with them. Yes. We won't look at that right now.
All right.
Good question. Yes.
Just trying to understand.
Yeah, no, you're good. Great. All right, so does anybody have questions on these exercises? So I asked you to try those out. Question. For the triple quotes, so write down, where did we do triple quotes? Was it further down? Shoot. Okay, we'll try triple quotes. What should I type? Sorry, I can't hear you very well. Say that again. Let's try it. Okay. So the question was, when we're using triple quotes, Python's supposed to print out exactly what's in between those. So let's try triple quotes to say hello, like this kind of stuff. Oh, so like this? Oh, yeah, good question. Let's do it. Woo, 10, fun things. Type 10. Hello, underscore. Okay, like that? Kind of that kind of stuff? Yes, good question. Here, let's.
So in this string, you insert one double quotes between them.
Yep, good question. So let's add some of those upper quotes in here too. Oh, sorry, not that many. Just one. Maybe one over here too. Okay, so that was a great question. So what's happening here is when we have triple quotes are kind of a weird thing. We'll maybe look at that a little bit later, but triple quotes are going to basically say, okay, triple double quote, triple double quote, triple double quote. Okay, everything from now on until I see 3 more triple double quotes, we're going to just treat that as a string. One string together, so we don't have to worry about a lot of kind of the weirdness. And we can also print those things out too. So we could add a print function at the very beginning. And we could print that out. So this is kind of weird with this width. Let me try to make this bigger for you. Okay, so we can also print that back out. So we did triple double quotes, and then it actually removed those triple double quotes, and it still kept all these double quotes in there too. It didn't break. So with those triple double quotes, I don't know if there's a faster way to say that without trying to get tongue twisted. We'll basically just take everything inside the triple double quotes, and we'll try and give it back like that. Even if we did, let's try \n in there. What happens? So when we return that, wait, where did that go? Hello. It was by the hello. Okay, so when we return the \n, that actually got a little confusing, but that's actually going to give us the new one. Well, let me put that in earlier so we can actually see this in action. That's confusing. Let's \n do it. Okay, so with the new line in there, with the \n, it ends up actually saying, okay, in the triple double quotes, if we're printing this out, let's also, or sorry, yeah, if we're printing this out, let's be sure to evaluate. So that's the only other kind of quirky thing. We don't have to go into that too much. Ask questions during the longer break and during the latter half of the workshop. Okay, any other questions on these exercises before we move on? Question?
So I put a capital P for print and with that.
So let's try capital P for print, and let's try hello. Doesn't work. So this is what we're talking about with the capitalization mattering. So even with functions, with variable names, it matters. With function names, it matters. Because Python doesn't know if you mean, if you actually mean lowercase print, it doesn't assume that for you. It matters. So. Other questions before we?
Is there a word for opposite of none?
Opposite of none. Not a particular word. None is a good one.
We use one numeric one, opposite of none, right?
I wouldn't necessarily. We'll talk about Booleans next. So we will talk about lots of concepts like that. I don't know if I have a perfect answer for that particular question. I wouldn't say opposite. Opposite's kind of a weird word. What's the opposite of for? Like I don't know.
What I meant, okay. Like 0 and 1. Okay.
Yes, we'll talk about Booleans and truth, truthiness in just a sec.
Okay.
We'll get there. Yep, we will get there. I'll talk about that. I promise. Only on these exercises before I move on, and then I swear I'll talk more about that.
Did you put the first one?
The first one, this right here. Okay, I'm going to copy this. You don't have to always copy this, but let's try this. What's total? What did you get? Cool. So then you probably did it right. What about the what? Oh, the type. Let's try it. Type of total. So it's a float. So even when it's negative, even when integers or floats are negative, they're types. So you can have a negative integer. Let's try type -10. That's still an int. You can also have a negative float. type negative 0.0 or 10.0. It's still a float, even though it's negative. Yes.
So for the second one, separate the ground of the
Yes.
So since the A returns A, I said so it returns 3 up to 3 times ground of 3 times.
Yep.
How do you separate those words?
How do you separate the word? Okay, so good questions. Let's go back in here. Let's just do this one. I'm going to cheat, and I'm just going to paste these initial parts in. So first we start A equals quick, B equals brown, C equals fox jumps over the lazy dog. So when we're actually doing this and we print it out, let's just look really quickly at what happens here. So I'm going to make this bigger one more time, and we'll take a look at the individual bits as well. So even bigger. Okay, so the quick, brown, fox jumps over the lazy dog. So how did we get the spaces in between? Was that what you're asking? Great question. So what we did here is actually inside of the print function, we actually had these, if you notice this part, like that part right there, what that is that's just a string with one space in it. The character in there is a space. So that's giving us those spaces in the end when we're using the string. So let's evaluate this kind of piece by piece in this print. So when we're looking at the print inside parentheses, we're going to look at everything in those parentheses first. We're going to look for the order of operations that we want to do. So first we're going to start with parentheses. If we don't see any parentheses, like in this case, we don't actually have parentheses in that print function right there. So we're going to start with multiplication and division. Now we have multiplication here, which is this A times 3, and we have this B times 3. So what we're doing first is multiplication. So we're doing A times 3, which is A is equal to quick, because that's a variable we just defined on that first line up there, A quick. So we're going to do quick. And then we're going to have that little string right there that we're holding on to right here. And then over there on B times 3, we're going to get brown. And then we're going to have those two strings that we're holding on to. So those are existing. And then we're going to do the concatenation. So then we'll start at the left. So we'll get the space. And then we're going to get the space quick. And then because we have this space right here, we're going to add another space to it. So it's going to be the space quick, space brown. And then the last space over here on the right side, we're going to do one more space, and then we're going to add C, which is fox jumps over the lazy dog. Does that make sense? I went really quick.
I'm still trying to understand how to get it to this thing.
Great. So that the way we're doing that is right here on this string, we have a space.
No, not that part.
Oh, okay.
Okay, when you say A, I say 3.
Yes.
That is quick. Brown.
So would you want the quick space?
All right.
Great. So what we could do, and that's actually can be kind of a weird thing to try. So what we could do is we say A equals quick space. So let's try and print that again. So now we get the quick, and then we actually get another space and another space there because we had that extra space in here. So we could go ahead and get rid of this. So now we get the quick, and now we have that weird thing with the brown. So we actually we could change B to equal to brown space, and then we can try it again. We get the quick, brown. We have that extra space. We can remove that extra space we're adding in there. And then we get that entire thing right there. So does that help answer that question? Perfect. Awesome. All right. Any other exercise-specific questions before we jump into the next thing? Okay, so one quick rearrangement that we're doing is because some of the TAs have pointed out to me that a few of you are running Python in a different way than would allow you to actually do the next part. We're going to skip briefly, we're going to skip one of the particular points we'll do next, which we were going to do, which was scripts. Oh wait, that might not be on my list, so actually we can skip that completely. And we're going to jump into another part. So if you see something that says, I think later on, like running scripts, we're just going to skip over that particular bit right now so that we can revisit it towards the end when we want to actually help you run scripts. Now, yeah, so we're sorry, we're going to skip that for right now. We'll help you get set up with that later on. Okay, same thing kind of with some initial stuff with comments and new lines. We already talked about new lines. The new lines are that \n that we talked about. And comments I could talk about as well, but they kind of get into scripts as well. So we're going to skim over that for right now and just go straight into something called Booleans. So scroll down to that Boolean section and we'll start there. I'm going to clear this up and resize it real quick for you. All right, so this is going to get back to your questions. So far, the code we've written has been unconditional. We're not making any choices. We're not saying, hey, Python, do this thing, if this thing is true. We're not saying, hey, Python, do this thing while this thing is true. We're not saying, for something happening, do something. So we're kind of just saying, okay, Python, execute this one line. Let's move on. So you might not always want to do that, and there's some ways that we can actually change that up that are going to kind of require us to know a little bit about the concepts of truth and false. We're going to get real philosophical right now. And we're going to have to know how these work in Python. So let's go ahead and type this into Python. So let's type in true and hit enter. So this looks a little weird because we're like, okay, what's going on? We have this thing. Normally when we type like Fernando, that doesn't work. What's going on here? Well, true is actually a little bit special. And it's the same thing with false. False is also special. Python recognizes those as things that it will actually interact with. So if we did type here and we did true, we would get a class of Boolean. So this is the type of the thing we're interacting with, which is a Boolean. Now, a Boolean is basically true or false when we're dealing with it. So Booleans hold two values. It's just only that true or that false. And when we're seeing that, it's always going to be capital letter at the first letter, so capital T for true, and capital F false. So keep that in mind when we're working with that. True is not the same thing, and false is not the same thing. The same way, false is not the same thing, and true is not the same thing. We have to just have that first letter and all the other characters lowercase. So let's go ahead and do these again. I think you'll see that we're going to get some similar things. We kind of walked through those, but we can go ahead and use type again for false. And type is still going to give us a Boolean. So now you can kind of tell how we differentiate between things that might look like they're a Boolean but aren't really a Boolean. And also the same thing, if we actually wanted to do type of maybe we have some string that we're saying is false. Well, actually, no, that's just a string. And the same thing if we do type true, even if it's the exact same case that we need, it's still just a string because it's in quotations. So let's talk about Booleans and equality. So Booleans become really useful when we want to evaluate the truth of something. So if I say 0 equals 0, what I'm doing in Python, because we actually already reserved that just single equals, so this means, you know, x equals 5 or something like that. So that's variable assignment, and we can't use that again. So we need to actually add an equal sign in addition to that. So let's say we want to know whether or not 0 is equal to 0, meaning, okay, is the number 0 also equivalent to the number 0? I don't want to assign 0 to 0 because I'd use 1 equal sign for that. I want to know, okay, 0 equals 0. Well, Python's going to say, yeah, that looks good. That looks great. Let's go ahead and do that. But what if I say 1 is equals, so we're going to use 2 equal signs, but what I'm testing for is still equality. What if 1 is equals 0? Python says no. It doesn't think that's equal. And we can do that with other stuff. We can say 54 equals 42. No, that's not true. We can also do that with strings. So we could say hello equals 50. No, that's not true. But what about hello equals hello? So that's true. So what Python's letting us do here is evaluate whether or not things that we are saying to it are in fact either true or false. So we can try and also do something else. And capital H, so good, great question. So let's try it. Let's say, is hello lowercase equal to hello uppercase? No, it's not the exact same thing. It's got a difference. There's an uppercase H in the second part, not lowercase h. So in addition to that, double equals, so let's erase this again because that's variable assignment. We don't care about that. Oh, thank you. Yes, that's be a little easier. So in addition to the double equals, we can also say, that's just saying, okay, is this first thing equal to the second thing? But what if we want to ask it something else? Well, if we want to ask it, is this first thing not equal to the second thing? That's another question we can ask. And somebody who read ahead, tell me how we can do that. Okay, so let's try this. Let's do 10 exclamation mark equals 10. So that's false because 10 is equal to 10. And what we're asking it is 10 not equal to 10? And all these double negatives are going to get a little confusing, but basically it lets you ask the other question, the other way around. Now, we can do this in other ways too. So we can say A is not equal to A. And that's also false because they are the same thing. We know they're the same thing. And we can also do, actually, this gets a little confusing with strings, but we could say, is A the string not equal to A the string? Well, okay, actually, A, even with double quotes, is the same string as A with single quotes. So if we actually did the same test with two equals, we'd say, yes, they're the same thing. That's fine. So this is one thing that gets a little confusing. Question, yeah. Great question. So these appear to be equal in Python 3. That's a great question. I don't go too much into these. This is not my strong suit over there. So that's a great question. So that is true, but if we wanted to, again, if we wanted to say it's not equal, that's false.
So it's basically not evaluating the types of the operand, rather it's evaluating the value of the operand.
Yes, yes, yeah, that's a good way to put it. Thank you. Okay, so in addition to this equality and this kind of not equality with the exclamation mark equals, we can also do some stuff with alligator brackets. Now, you might remember these from math class when you're sitting there trying to figure out is one thing greater than the other, is one thing less than the other. Well, we're doing the exact same thing in Python. Now, this is where there's actually going to be a few weird things that'll come up right now as you're trying to do these. So let's first really quickly get one of those out of the way. We'll just use 50 and 50 as an example. So remember before how I said the spacing in these operations didn't really matter. So we could do 50 is not equal, or sorry, let's just do 50 equals 50. So this is true, right? 50 equals 50 is true. We can do this. We can do 50 equals 50 is true. That'll work. What if we try and do that? That doesn't work. So when you're thinking about how these things that we're typing in work, remember that when we want to know equality or we want to know not equality or we want to do stuff with these alligator brackets later on, the actual things we need to put together, this is one unit. This goes together. The double equals goes together. The same thing with the not equals. The not is exclamation mark. The not equals also goes together. Those always have to be without any space in between because we need to think of them as one unit there that we're using. So keep that in mind as we're going through, because if we don't do that, things can get weird or break.
So 2 equals 2 equals 3.
2 equals 2 equals, is that what you want me to do?
Yeah.
Okay, well that's interesting because how is this getting evaluated? So let's see. I don't know how this is getting evaluated. Giving me all the fun ones. I'll do that in a few minutes. I'll make Albert explain it now because he'll have a chance to do that. Okay. There we go, and then there you go. So we're going from left to right. We're doing, since these aren't multiplication or division or anything else, it's not using the order of precedence on the first. So that's exactly the best explanations. 2 equals 2. What does that evaluate to?
True.
Exactly. So it evaluates to true. So really what this part is true. And then says, okay, we're still going left to right. So true equals 3. False. Yeah, correct. So it's false. So that's why we get the false. Oh, I'm glad I have Albert back there saving me. All right, so we talked about those inequality tests. We can use those inequality tests on numbers. We can use those on strings. But let's go back to actually trying out these right here. So they have the same meaning as in math class. So let's try them out. Let's try 1 is greater than 0. Let's try it. We're going to do some audible answers here. 1 is greater than 0.
True.
Okay, true. Now let's try 2 or 3. Let's say 3 is greater than or equal to 4. What is it? I need a true or false? False. Okay, great. So let's try -1 is less than 0. Quick answers. There you go. Boom. And then 0.5 is less than or equal to 1. That's right. Okay, cool. So that's how you use those basically. Try a few of those out. Get a few numbers in, test them out, type them in. I expect to see hands on keyboards because I want to know that you know how to do it. And then we'll move on to the next part. I promise. But I have to hear enough keyboards typing that I believe that you've done it. Okay, I believe you now. So in addition to those operators that we were using to check for truth and falsiness when we're comparing between two things, whether or not they're equal or greater than or less than, we can also use another one which checks if something is in something else. So this is really useful when we're dealing with strings. And the way we do this is we have some string like hello, for example. And maybe we want to know, well, is there an H character, an uppercase H, inside hello? Well, the way we could do this is we could say, okay, let's use H, uppercase H, in hello. So what we're asking Python is we're saying, is H in hello? Can you tell us that? And Python's saying, yeah, it's true. Yeah, H is in hello. Now, if we wanted to do, is H-O in hello, so maybe, or that's a 0. If we wanted to do like H and then the in character O, well, that's not true because it's looking for that specific characters, those two specific characters right next to each other. So if I did like hello, oh, sorry, that's also false because I need a capital. So that would be true because it's seeing those in the end.
That would
So
point to where it found that instance.
Yes, let's try it again. So let's use H.
Or how many times should we?
Yes, we can. I won't do it now, but we could. So what we're checking for with in is this thing in there anywhere? If we want to find how many times it's in there and count that many times, we need to do a few other things to do that. We could look through every part of it. These are kind of interview questions now. We're like, okay, what's the best way to tell me if this substring is in this longer string? And that's the most efficient way to search through. Do we look at the first character, then the second and the third, or do we look at the first 10 others? So there are a bunch of different ways we could do it. And yes, we can, but not as easily as I would like to just write out now.
Pointing to the first instance, or
Pointing to the first part of it?
first instance.
The first instance of H in hello, for example?
Yeah, like this is the index one, right?
Yeah, that is index one. I don't know if there's a quite super easy way to do it. Maybe Albert has something genius back there, but I think I'd have to do a little bit more coding to get that first instance of it in there. We can do that during the ending if we want to take a look at that particular case.
How about how many times you have?
That's kind of the same question. So we'd have to do a little bit more work to get that. And there's another question back there. Yes? Let's try it. Yeah, that's a great question. So let's say, is 1 in 100? Well, no, it doesn't work. So what that means is actually when we're using in, we're actually going through every little bit of the string and looking for the occurrence of the initial parts of the H. So if I tried, yeah, no worries, I'll answer that too. So, and the same thing if we're doing integer in 100, it's going to get a little confused because it doesn't understand really. So it's expecting the string. I'm trying to think if there's another way you could use in other than strings.
Could you use like quotes in front of around 1 and test?
Yes, you could. So let's try that. That's a good question. So maybe this was what you were going for. Sorry, I maybe misinterpreted that. So you could, yes, you could definitely do that. When these things are strings, they'll be treated like normal string characters, and we'll be able to find them in there. So even if I do, 0001 at the end, yes, it's in there. It's just hiding at the end. Now, we could use in with other data types than strings. It's not just strings. So there are other data types we might look at towards the end, but there's something called an array here, or a list. And I could have different things in this array. So I could have hello, I could have 10. So these are all different data types. I could have true. So this is an array. We won't look at it too much, but I could say, let's say 10 in this array. Well, yes, because it's hiding there in the middle. So that would iterate through everything in there and find 10 for me. So yes, you can use in other ways.
I have a
Go ahead, question.
So if you were able to assign like for example, my car, and you put Honda, and then you would say, is Honda in, or actually,
Like
is
this?
my car in Honda? Or is my car equals to?
Oh yeah, let's try all of those. Let's try a few. So we set a variable called my_car and set it equal to the string of Honda. First, let's see, is H in my car? Yes, because my car is actually Honda. My car doesn't have an H character in it. It's actually, hey, is it in the string? Is it in the value of the my car variable? So that's true. Let's do the next thing you wanted. So we wanted to know, okay, my car, what was the, sorry, remind me, what was the next thing we wanted to try? Oh, okay. I thought there was something else. I'll remember it.
Fine.
It seems, yeah, we can definitely get to that later too. That'll be ending stuff. We'll write a list of things to like Python fun stuff.
I think back to the mathematical.
Yes.
Boolean.
Yes.
I tried to assign, for example, number sign equals to 3, and I would try to put.
Yes. So you tried to do. So yes, you stumbled onto something. So you tried to do this equal to 3. Is that what you did? Okay. So the reason this doesn't work, and this is actually a good point for anybody who typed the pound character into the Python interpreter. We didn't really cover this, but the pound symbol here is actually saying, let's start a comment. So when we see pound, Python goes, okay, I'm ignoring whatever's on that line, because that's a comment. You just want to read that yourself later. So it's saying, okay, equals 3 is not evaluated. It's going to skip over that. And then we could say like 10 equals 10. So our variable ten equals 10. So that's basically saying, okay, ignore this line. So that's why it didn't work. If we wanted to literally evaluate the pound symbol in a string or something, we could do that. We would just have to be sure to escape it.
The pound something stands for something else where
Yes.
Python wouldn't be.
Yes. So pound in Python, yes, this character in Python says ignore the rest of the line. We're not gonna look at it, or Python's not gonna look at it. That's there, and you use that in code a lot when you're writing comments to other developers. You say, hey, here's how my code's working. You put the pound symbols in front of that so you can do that, or you annotate your code with it. Great question. So we can also use not in. So the same way we could do the exclamation mark equals, we can also do the not equals. So let's say not in, let's say H, capital H, not in, capital H, hello. Well, that's false because it actually is in there. Let's say hi, lowercase. It's true. Capital H is not in hi, the string. So questions?
So just to get it right,
Yes.
false and true on the second line under the thing you just typed.
Yes.
Called a boolean.
Those are booleans. Yes. So let's see. So let's say we want to know what the result of this, what the type of this is. Everything in there is going to be evaluated, and it's going to be a boolean. So you can always test that. If you're confused or curious, just use type. Type is going to tell you exactly what you're dealing with. Great question. Okay. So let's try one more of these. You basically get this now, so we'll move on really quick. Seattle's not in Python Redmond Python workshop. That's true, because it's in Redmond. Great. What time? How's my time? How am I doing?
Do you remember the setup first?
We may. Sorry, I just want to make sure. So we're not going to do scripts yet. We'll do scripts at the end, but I'll give an announcement. Good point. So comment new lines. Booleans, equality. Okay, we covered a bunch of great stuff. We have 10 extra minutes right now. And in this 10 extra minutes, I want everybody to try something. So we're all working in the Python interpreter right now. So we are talking directly to Python. Now, in order to get into the Python interpreter, we might have done a few different things. We might have opened up some program on our Windows machines or on our Macs that was a specific thing just to load up the Python interpreter. We might have also gone in and opened up another program called something like command prompt. So if we opened up command prompt, we might have typed in Python there. We could have done that. It may or may not have worked. And we could have gone maybe into some other program called terminal. And I'm using two operating systems on the same computer, so this is why it's a little confusing. And we might have done the same thing. We might have typed in something like Python and then gotten into Python. Now, in order to do the next part, we need to not only be able to talk to the Python interpreter, we also need to be able to talk to the operating system. So we need to say, okay, I want to deal with files that I've saved on my Windows machine. I'm not just talking to Python, I'm talking to the operating system. So please go ahead and everyone right now, open up the command prompt, the terminal, the shell, whatever you have on your machine. And let's, as a command prompt for an example, please, how do I get out of this? There we go. Okay, so go ahead and type in Python and see if it loads up Python. If it does not, please raise your hands. Or if it does not, please know who you are and stay here and ask for help in the next 5 or 10 minutes, because we need to get that working for you to do the next part of the workshop. So raise your hands high so we kind of know who you are, and make sure you talk to a TA. Everybody else, we have breaks right now for the next, I think, like at least another 10 minutes. So 10-minute break, maybe a little bit longer. Be back by 4:50. So back by 4:50. Feel free to ask other questions, even if you're not set up. So, yes, it's same stuff, all getting set up. Okay, TAs will be coming around. I'm just going to work my way. Yes, so this needs to be, that needs to work. That's a good point. Okay, so quick clarification. This is probably a lot of people's question. Thank you for bringing this up. If you see these triple alligator brackets, you're in Python. You're talking to Python. If you need to get out, there's 2 ways you can do that. Some machines will allow you to use Control-D or Command-D. You can also do exit. And exit is a function that kicks you out of Python. So you need to be able to get into Python from the command prompt, not from Python. So you have to be able to go from some character like it, let's see, what's a good example? You have to be able to type in Python and then see the triple alligator brackets. You shouldn't just already be seeing the triple alligator brackets. Yes, to get out. And if you have questions, just raise your hand so we can check.